All right. Thank you to those who voted in the most recent poll. Of course, you can see that the majority asked for a pumpkin. Happy October. We're coming right up towards the end of the month, and we all know what that is. So, in one of my earlier videos, we just went with any lips and just wandered away there. But what I'm going to show you this time is we're still going to draw ellipse, but a little differently. Now I'll show you what I'm talking about here. I'm going to say function of x is square root of 1 minus x squared. And we're essentially going to be composing this function, or I'll leave it on, with, I forgot which way it is. No, it's not that way, it's the other way. We're basically going to be putting sine of x in there, and here's a difference. So there's that, and then here's what sine of x normally looks like. You can see here that the way function composition works is rather than doing square root of 1 minus x squared, this is really 1 minus the sine of x squared. And with that, we're able to get these nice bumps at the top that they would see on a pumpkin. And we're still going to need this, but we don't want this in our final work here, so we're just going to turn it off. And we're going to do something similar at the bottom here, and let's shift it up by a little bit, and then for our next function, it's going to be the same thing, but instead of, we need to do two things here. First, we need to flip the entire graph, and so we do that by sticking a minus sign in the front. And then we'll need to subtract one here. At this point, you may be thinking, okay, well, we're at the same number here, and we're subtracting the same number on the bottom. So can't we just put a constant or a variable to do that? And to that, I say we can't. So we want the height to be 1, and if we want the total height to be 1, this is you really want to do a half of each. So subtract the height, and then the total gap effectively is 1. Okay, maybe a little more than that since 1 is actually here. Let's not get too bogged down on that. Let me make this a little bit bigger, and then we'll find out what this and conveniently, I'm just going to go 3 bumps for simplicity. And conveniently, you can see that we are provided with the start and end point. So this is minus 3 pi and a half, and the other side is going to be the same thing but made positive. And it'll be the same restriction that we apply to the bottom graph here. So the next step here would be to connect the two, and for these two pieces here, I still think it's good if we kept it round. And I'm not going to do any special tricks for this one. Instead, we're just going to eyeball it. So we're going to start with our usual ellipse, and the strategy here would be to start with an ellipse, and we'll just trim off. We'll just omit whatever's in between here. That gives you a hyperbola, by the way, if you subtract the y squared. All right. See, let's leave the 1 so that we do have a better idea on what the width is going to be. And for now, I'm just going to estimate it at around this 5.5 mark here. And if we're going to do that, we'll leave it this way just so at least it's easier to read. So you know what the distance is between here to here, and then you square that. And for the height, I'm just going to put it out at the maximum here, which is 3. And so this would just be 3 squared. And now, I think at this point, if we stretch this enough, we'll be able to get an intersection point between here and here. And there's no quick way that I can explain to you on how to do that. And so for now, we're just going to go with the idea of just estimating it. So the 4 is really close here, and we'll just zoom in just to see if we can get close enough. You can see that this line is almost riding that line there. It's just a shy above, and so it looks like 3.875 is going to get us as a good mark there. And we'll just use this number here as a way of trimming. And if you want to be extra precise, you would also trim off whatever you have in here. So this is minus 4.701. So in this case, for us, we'll be using these numbers as our boundaries. So that cleans up the bumps a little bit. It trimmed off the excess ends. And for this one, of course, we need to say excess less than or equal to the minus of that, and also need this to be greater than or equal to that. And this one you can see is more interesting than is having any lips if you want a bit more character to it. If you want more bumps, you would need to squash your harmonic wave. You will need to increase their frequency. So since we're here, or why not let's do that. And so I want to make a folder, and that folder is going to be called. Hang on a minute, that's not how you make a folder. You'll make a new folder. Let's call it that, and this one we'll circle back to momentarily. I just want to at least give you a way of. I don't want you to feel that this is the only way of, or this is the only bump size they can get. That is not true, of course. Stable that, collapse that to clean that up, and we'll still do. Right, it's the other way around, as we just saw in the beginning of the video. So if you add a factor in front of sign of blank x, you can see that you can get more bumps like that, or if you want fewer bumps, you would be using a smaller number, and for to make things easier, just use a decimal so you know that any number that they're dropping. Any fraction they're dropping less than 1 is going to get you wider bumps. If this is what you want, I mean, by all means, go for it. Or if you want more, just put in a value that's greater than 1. It could be 1. It doesn't have to be a whole number. It can be a decimal. So I'll at least get that point out there. And now the next piece naturally would be to color it in. And sure, we'll do that. So to do that, we'll be using the same function definition here, and we'll get the big ones out first. So I chose the upper half here, and because as this is the upper half, we want to use a greater than. If you chose the bottom half first, it would be less than. If you prefer that way, that is how you would do it. And of course, we need the bounds here. All right, and then we'll need to fill in the rest. That's fine. So this, I believe, we can just use the same equation, and we'll just say it's less than or equal to 1, and it'll catch both sides. We don't need to write it twice, or we don't need to decompose it. Just use that inequality to save yourself some headache. Let's color this thing. I'm gonna go for an orange look. If you want to go purple, I have seen purple pumpkins around, by the way. I'm sure you have as well. There we go. And now the next piece would be to do the stem. The stem is pretty straightforward. I'm gonna go for the square root. Since the square root, yeah, it's easy to control where you want to come out of. If you use a if you want to use a different function that's also coming out like that, if you want to use a use a like a logarithmic function, and you can't do that. What you would do is you would just set your equality. You would say y is less than or equal to, or y is greater than or equal to that, and you'll just trim it off there. And in fact, just seeing as how funky these numbers are, um, there's not much of a gain in using a square root, despite how easy it is to pick a point. All right. I'm going to collapse this, and then I'll make a new folder. I'm going to call it stem. So let's just play with a few functions for now. If we have a log of x, what does that get us? That's an interesting shape, actually. I'm actually do that just so that we're not using conic sections all day. Or in fact, let's just go for it. If you want the conic section, the hyperbola would be the one to go for. So that would be 1 plus x squared as our base. It's one or the other. So it's x squared plus y squared. Okay, there we go. And now we'll just solve for y here. So I subtract x squared, multiply both sides by either minus, and we'll take the square root of that. There we go. There we go. And now we can apply our function transformations here. Let's have it starting and around this point here. So that is 1/4. We have a width of 1 here. So we're going to add add 1 to get this line to the center, and then we're going to add another 4 to get it there. 2.878. And this is actually 1.5. That works. And then I'll just duplicate it over. Yeah, for those bothered, sure. And this one we would move it a tiny bit. We'll apply the same kind of logic. So we would subtract, well, we would add 1 to get it centered, and then we would subtract the 0.5 we want to get it over, so it'd be minus 0.5. So that is there. And so if we subtract okay. And then I say let's cut it off at the 1 here. You can make the stem however you like. If you're here just to make the body of the pumpkin, that part's already done. If you want a stem or to stick around, thank you. So be x is just put 0 for the convenience, and then we'll just close it off with the half circle. And we'll just go let's go half to the left or right. Then we'll add 4, and then we'll downsize it. So at this point, just so we have the radius. And we'll flatten this out. And we'll stretch it by just a smidge. And then this would be from 0.145 up to 1.022. Okay. And then that would tell us what the upper bound is on this one. So for the left side is 0.145. And for the left side is 1.022. Okay, so now we have some kind of stem that we can work with. So now to fill it in, let's grab this. So I just copy the blue line, and this is going to be the top here, and what's on the bottom is going to be this orange line here, and that is this guy here. So if you're unsure on which ones because you already colored everything like I did, you just click on a line and it should tell you which one it is. All right, and then this one should be bottom line there, and this line should be the top line. And if we want the assurance, that's funny. How did this one know what the boundaries are? All right, for the last line, we'll still need this one at the top here. And this would be encompassing that top orange line there. No, we don't need the inequality for that one. We just need the function for it. Clearly, we made a mistake. Okay, and then the boundaries for this is going to be at looking like that 0.5 mark there. And so now just to get the colors the way you want them to be, there's your stem. All right, so hopefully you found this helpful in some shape or form. Oh yeah, quick tip: if you want, oh yeah, the reason you see this green line over the orange line is because we drew this 1 second. So if you want to change that, you just move the stem to the top, and an orange line would draw on top of it. Hopefully you're able to find this video helpful. If you did, please consider leaving a like on it. Else, let me know what this video could have been different. What was it that they were looking for that you didn't see on here? All right. So again, that's the end of the video, and I'll see you in the next one.